We are happy to have you join us for Winter Weather Preparedness Week, and today's topic is snow. So let's start with some facts about snow. A snowflake begins to form when water vapor freezes onto a dust particle in the cloud in a phase transition process known as deposition. This creates a tiny ice crystal. As the ice crystal slowly falls to the ground, additional deposition occurs, causing it to grow into the snowflake that we know. As long as the temperature remains below freezing, the snowflake will continue to grow. However, snow can still occur when the temperature near the ground is above freezing, as long as the air above freezing is not too deep. This is typically 1,000 feet. Snow forms from the aggregate of these ice crystals, whereas grapple forms as a result of greater riming or water coating. It becomes icy in contact with the dendrite. This creates pellet-shaped snow with a conic shape formed as it tumbles to the surface. Grapple is sometimes referred to as soft hail. Even if it is somewhat above freezing, so long as it's cold enough in a range of temperatures favorable for producing snow in a large part of the atmosphere, snow will fall to the surface. Given enough time, it can be enough to shovel and make for a messy commute. Even when temperatures are entirely below freezing, the moisture content of the atmosphere and exactly how far below freezing you are is important to the process. In addition to all the various shapes a snowflake can have, it also holds different amounts of moisture, which we refer to as its density. Wet snow contains more moisture and typically occurs in storms when the air temperature near the surface or within the atmosphere aloft is close to freezing. Wet snow is also more typical in situations where the storm is able to pick up lots of moisture from oceans. The temperature at which snow crystals form, and to a lesser extent the humidity of the air, determine their different shapes. Wet snow, being more dense and heavy, tends to pack down on itself when it accumulates, more than dry snow. Because of that, the same amount of liquid, let's say 1 inch, may turn this into 5 inches of wet snow, but 20 inches of dry snow. The snow to liquid ratio is quite variable and changes during a storm and from one area to the next. Nor'easters are low pressure systems that track along the east coast of the United States and produce heavy precipitation and strong winds, typically out of the northeast, hence its name. An example of a nor'easter is shown in the radar and surface chart on the left. They also tend to track along a major commuting corridor in I 95, so the exact path of these powerful storms can make a world of difference with regards to impacts. If the storm tracks along Cape Cod, then Vermont is more in line to receive heavy snow. If the storm tracks well offshore, what we call the 40 north 70 west benchmark, then we are too far from the system. However, the cold air on the northwest portion of it provides usually dry, light snow to Vermont. A good rule of thumb is that if Boston is going to get a lot of snow, then don't expect as much up our way. On the other hand, if the storm tracks close to or over interior New England, we can get heavy wet snow or a mix of precipitation with warm air near the low. This can lead to a greater risk for power outages due to snow sticking to limbs and power lines. Systems that come out of the north are more likely to produce dry snow. Storms out of the north tend to be accompanied by frigid air. These lows descending out of the north that move fast across the northern United States are called Alberta clippers. These low pressure systems affect the Vermont and northern New York area as they track eastward from Canada. Without a connection to moisture from subtropical waters off the Gulf or Atlantic, these systems draw moisture from the Pacific or nearby lakes that get modified as they cross North America. An example of an Alberta clipper is provided here with the composite radar image. Blizzards are another type of notable winter storm. In order for a blizzard to occur, the following conditions must prevail for 3 consecutive hours or longer. One, you need sustained winds or frequent gusts up to 35 miles an hour or greater, and considerable falling or blowing snow that reduces visibility to less than 1/4 of a mile. The strong winds combined with the low visibility make traveling extremely dangerous. Whether driving or walking, you can easily become disoriented and lose your way, as well as having the wind blow your vehicle around on already slick roads. Lake effect snow showers are created when cold, dry air passes over a large, warm lake, such as Lake Ontario and Lake Champlain. These lake effect snow showers pick up moisture and heat from the lake, and they augment the cold, dry air that's over the atmosphere and precipitate as snow downstream. These showers can last for hours over the same area or meander and affect several areas downstream of the water source. Lake effect snow showers can extend over 100 miles away from the water source. Lake effect snow being a local intense band of snow uh, that's often accompanied by gusty winds can catch people off guard. It can persist for several hours and meander. So, intense lake effect snow bands, you can be in clear conditions one moment and then be in very heavy snowfall capable of even lightning or 12 inches or more of snow within 12 hours. So, lake effect snow is something important to pay attention to, especially if traveling across northern New York. Within all different types of storms, snow squalls can develop, making conditions particularly hazardous. Snow squalls can cause whiteout conditions and can be fast moving. So, one minute you can be driving in light snow or no snow, and the next minute you're driving in a snow squall with 2 to 3 inch per hour snowfall rates and visibility is less than 1 mile. They often occur with cold fronts during winter. They are like a blizzard bundled into 30 minutes, featuring gusts of 35 miles an hour or greater and whiteout conditions that can catch motorists off guard. Here's an example of what a snow squall looks like. Just imagine a perfect blue day, and then you have these whiteout conditions following. Upslope snow occurs as a result of air flowing up the mountain summits. In the absence of any weather system, winds moving up a mountain barrier creates an opportunity for precipitation. Cooling can also transition any rain to snow, so early and late in the season, snow is often elevation dependent. Snowfall can range from a trace in the valleys to several feet in the mountains. Generally, as you gain elevation, the temperature decreases, so you could have rain falling in the Champlain Valley and snow accumulating in the Green Mountains. It all depends on the temperature profile. Be ready for changeable road conditions and reduced visibilities approaching high terrain. Be sure to check conditions and forecasts along your route if you need to travel. Depending on the speed of winds and how unstable the atmosphere is, snow will become favored in different locations. Listen to forecasts about whether moisture is trapped below ridges or whether snow will fall downwind of mountains. In the situation where snow is falling downwind of mountains, it will typically favor regions of eastern Vermont. This is unblocked flow. Where snow is favored along our summits, that is often semi blocked flow. And for situations where snow showers persist and are trapped within the valleys, we call this blocked flow. It is advised to have a winter storm kit in the trunk of your car in case you get stranded. Some supplies you may want include blankets, non perishable foods, flares, a shovel, a bag of sand, tire chains, a flashlight, windshield scraper, and jumper cables. And don't forget to have your phone charger with you as well. When snow capable of causing hazards is forecast, the National Weather Service issues the following three products to raise public awareness of threatening weather conditions: a winter storm watch, a winter storm warning, and a winter weather advisory. These products can also be used for a combination of snow and or wintry precipitation. All of these products will be disseminated on NOAA Weather Radio and are online at our website, weather.gov/Burlington. Our winter weather advisory criteria is an event snow of 4 inches and for a winter storm watch or warning of 7 inches. Most locations on average experience over 50 inches of snow per year, and several of our higher elevations experience over 100 inches of snow. The jet stream is strongest in winter, and so winter weather such as snow will likely occur every 3 to 7 days across the region. So be prepared so you can enjoy the winter season while staying safe. For more information, visit on the web at www.weather.gov/Burlington. Like us on Facebook and follow us on X, and be ready. Use our winter page as well to go through the different tabs to review forecast information this winter. Stay safe and enjoy the winter. We hope you appreciate it and learned something new about snow today. Thank you.